Hello, everyone, and welcome to this video. I had a question from the classroom that I thought I would answer today. It's a question about finding the upper and lower boundaries. Sometimes we call them the real and the apparent limits for a statistical measurement. We use it a lot when we're dealing with class boundaries and class limits. So I'm going to show you a couple of examples of how to do that from the textbook. So let me share my screen at this time and show you the actual page from the book. So here are the exercises in question. For exercises 17 to 22, give the boundaries of each value. So here they've given us a measurement, and we need to find the upper and lower limits of that measurement. So when you do this, you need to create an interval where the last digit in the interval is 5 and the interval is 1 decimal point or decimal place more than the actual measurement. So let me show you what that means. Let's do this. I'm going to share my whiteboard here. And this is another problem that I was doing earlier, but let me go to a new whiteboard. So if my measurement is 7 feet, what we want to do is find the upper and lower boundaries for a measurement. So what we're going to do is, first of all, we're going to decide step 1. Step 1, you ask yourself how many, so we determine how many decimal places are in the original measurement, okay? And you do that just by looking at it, all right? Well, then step 2 is to determine how many decimal places are needed in the boundary. And the decimal places that you need in the boundary, the answer to this question is always 1 more than the number of decimal places in the measurement, okay? And I'll go over this when we go over the example, so don't worry. And the third thing you want to do is the little bit tricky part. It's just arithmetic. Step 3 is you add or subtract, or actually I should say you subtract and add because the lower one is subtracted. So subtract and add the amount to the original measurement. So what that looks like is this. This amount always has 5 in the last decimal place, and I'll explain what I mean by that in a minute. So here's what this looks like. Let's say, for example, my example measurement is, my example here is find the boundaries for measurement of 7 feet. That was our, that was number 17 in your book. So 7 feet doesn't have any decimal places. There aren't any decimal points in this number. So the original measurement has 0 decimal places. Okay. The number of decimal places in your boundary is going to be 1 more than that. So that's going to be 1. There's 1 more than 0. And the way we construct our boundaries is as follows. What we do is we take our measurement. You take your measurement. So your lower boundary, let me start back here. So when I want a decimal place, I'm going to have 0 and a decimal point, and I'm going to put a 5 there. So 0.5 will be the amount that I will add or subtract. Okay. So now we're going to say that your lower boundary will be 7 minus 0.5. If you need a calculator to do this calculation, by all means use it. 7 minus 0.5. This is 7.0 minus 0.5. This is 6.5. And don't forget your units. 6.5 feet. Feet because the original measurement was in feet. Okay. Then we go and we do the upper boundary. So the upper boundary is going to be, the upper boundary will be your measurement, your original, plus 0.5. So this is going to be equal to 7.5 feet. So we would say that the boundaries for this measurement would be, you would write this as 6.5 to 7.5 feet. And 7 is right in the middle of that interval. So this would be your answer, okay? Now I'm going to show you another example from the book. So let's do number 18. 18 is 6.3 millimeters. 6.3 millimeters. So 18 is 6.3 millimeters. So we're going to go here. We're going to, this is problem 18. I'm going to share it here. So I'm going to move the whiteboard. This was actually, this example was problem 17 from section 1.3. Okay, we're going to do problem 18 as well. So this says we're going to do the same thing. So we're going to find the boundaries for a measurement of 6.3 millimeters. Millimeters. So step one, if you remember, is to find how many decimal places are in the original, and then how many are needed for the boundary. So we have 6.3 millimeters. So our original measurement, this is step one. Our original measurement has one decimal place. We're talking about one place after the decimal here. The 3 is after the decimal, one decimal place. Step 2 is to figure out how many places the boundary needs. It needs one more than the original. So step 2 is boundary needs one more decimal place than the measurement. So that would be 2 decimal places, or 2 decimal places. So when you create your interval, you're going to say, all right, so when we create the interval by subtracting and adding. Now we need 2 decimal places. So we're going to have 0 point, and then we're going to have a 0 there. And the last decimal place always has a 5 in it. So this is my second decimal place. It has a 5, and I put a 0 in for the other one. So we're going to subtract and add 0.05. So when I do my lower boundary for this measurement is going to be the original measurement minus my my amount that I figured out that I was going to add or subtract, which in this case is 0.05. Okay, so what I'm going to do here is I'm going to take just a little bit wider so I can write underneath it. Now, my lower boundary will be my original measurement, which is 6.3 minus 0.05. Okay. If you need a little help, use the calculator, but you should find that that comes out to be 6.25, and don't forget your unit, 6.25 millimeters. Okay. Now your upper boundary will be your original measurement plus 0.05. So this is going to be original measurement. Let me erase this because I wanted to write it in a text box and okay. So my original measurement upper boundary is my original measurement plus the amount that I found in the previous step, which in this case is 0.05. So this becomes my upper boundary for this problem is 6.3 plus 0.05. And this becomes 6.35 millimeters. Okay, so when I write my answer for the question, what I'll write is I'll write my interval as 6.25 to 6.35 millimeters. Okay, and that would be my answer. When you actually show the work, you only have to show the calculation down here that I did. I put the steps in there to help you. So again, final answer on this one, 6.25 to 6.35 millimeters. And this is problem 18 of section 1.3. That's my little overview on creating upper and lower boundaries for statistical measurements. I hope that that's been helpful to you. If you have any questions, you can feel free to contact me. And I'll see you in my next video very soon. Stay safe, everyone. Bye for now.